Hello and welcome everyone to the coffee talk of the EFCE Early Career Chemical Engineers section. We are the Earlies section, and what do? We try to bridge the gap between graduation and professional life for chemical engineers. And we try to do this by sharing experiences, insights, and information between us all over Europe. And at the same time, we try to offer upskilling opportunities. So if you are interested in what we do, please check our website. This is the third event of our Coffee Talk series. And we are very happy to welcome today the Education Working Party from the EFCE. In this series, we try to make people familiar with what EFCE does, what different sections and working parties do, and this also means what are the possibilities for the career of a young chemical engineer. So at this point, I will give the word to our moderators, Theodoros and Alper. So please, the floor is yours.
Thank you very much, Kseniya, for the very nice introduction of our section. As the chair of the Early Career Chemical Engineers, I'm very happy of co-moderating this coffee talk with Alper. Today we have with us two members of the Working Party of Education who will present us the work that they are doing in their Working Party. So the two members are Dr. Hermann Feiser. Let me do a small introduction. He has worked in the chemical industry for almost 3 decades. He worked as a scientist in process research for DuPont and BASF, as well as staff to the member of the board of BASF responsible for research and development. Today, he is responsible for the global sustainability management of BASF battery materials division. And he has also been a leader of the EFC for more than 20 years, serving as a board member, as scientific vice president, and as president of the federation. And today, he is the chair of the EFC's Working Party on Education in Chemical Engineering. And the second speaker is Professor Florence Vermeer, who is a tenure-track assistant professor in the CREAS group, I'm sorry if I spelled this wrong, of the Department of Chemical Engineering at KU Leuven in Belgium. The research of Professor Vermeer in her group involves the development of multi-scale modeling tools for applications in pharmaceutical reactor design and combustion of renewable fuels. In her group, they aim to innovate chemical reaction engineering with automation, computational design, and data-driven modeling. Florence obtained her PhD in 2019 at Ghent University, working as part of the Laboratory for Chemical Technology. After that, she joined the Green Group at Massachusetts Institute of Technology as a postdoctoral fellow, supported by the Belgian American Educational Foundation. At KU Leuven, she teaches reactor engineering and data science-related courses. She is an active member of the EFCE Working Party of Education, the National IE-NET Chem Expert Group, and the Faculty DI Committee. And besides her commitment to science and technology, Florence, her greatest achievement of the past years is raising a little boy called Felix. With that, I would like to give the floor to our speakers, who will give a 20-minute presentation of their activities, and then this will be followed by some questions that we have prepared for you. So, Herman, the floor is yours.
Oh, I'll try to share. Thank you, Theodoros, for the very kind introduction. And I didn't know you were telling stories about our lives, you know. Maybe just, you know, for the fun of it, you're aware I'm heading the Chemical Engineering Education Working Party of the EFCE, but I'm not a professor. I work in industry, right? I'm not even a chemical engineer. I'm a mechanical engineer by trade. Have never worked anywhere else but the chemical industry, though. It's kind of interesting. And I'm actually was Involved in all of this education from the very first days in the 1990s, when we were still trying to figure out how the ECTS, the European Credit System, transfer system would work. So the 60 points that you see nowadays on your annual credit balance, that was us. Sorry for that. All right. Today, I thank you all for the interest in this working party and what it does. I'd like to show you a little bit about how you shape chemical engineering education, how we try to shape chemical engineering from the point of the EFCE and the EFCE's working party on education. Now, the working party, first of all, it brings together good practice promotion, right? You can see the graph with the the map of Europe, and all the blue countries, that's the countries that are participating in the working party. We have a few small gaps, like we lost Ireland, Austria is not there, and there's a bit of a gap on the eastern flank of Europe. But otherwise, we're really well in prison. And the first idea is that, of course, engineering associations in all these countries are part of developing chemical engineering education. They are partners in the dialogue with the universities on how to teach chemical engineering. And they need to learn from each other to make sure we're actually pick the best practice and not just some, how you say, no longer appropriate ideas on how to teach. That is the first thing. It also brings new ideas, new requirements into the system. And we've talked about chemical engineering education. And the last few years, there were two big subjects. And it's digitalization, nowadays always called AI, but hey, we used different words before for the same thing, in ethics. There's the question of continuous professional development has become much more prominent over the last 15 years or so, mainly because mobility has increased, right? Engineers from all countries nowadays move around Europe and work in other countries where the local education system does not fit to the education system they went through. And one has to pick up on that and do things. And obviously, there are conferences with and about how to teach and what to teach. The second big part that the Working Party does is it influences policy, and I'm going to talk a bit about the EU Bologna process just in a moment, and of course about the ever prominent question of STEM education before university. Now, the two blue ones here on the slides, that's what we're going to have to dive into for a moment here. Let me start with the Bologna process. You're all aware that there is a three-circle tertiary education, bachelor, master, and PhD in chemical engineering in Europe. And it wasn't always like that, right? This is part of the standardization we've seen in Europe as part of what is called the Bologna process. We started with that famous conference in Bologna about 30 years ago. What also was developed in this point was a differentiation between degrees, one particularly on the PhD level, looking into research-oriented thing, you know, the stuff that will get you to the next Nobel Prize, and the other part looking into the more application-oriented education, making sure you can actually build a bridge and it won't collapse when somebody steps on it, which is kind of rather important when you are an engineer, right? Another thing that happened in Bologna was the requirement that our education has to be in modules, and people will have to be able to build a degree by picking modules. Similar like you can build a house or a toy house from Lego bricks, right? You can choose different bricks, but it will still be a house. And the famous diploma complements, that was also something that was developed during the Bologna process. Now in the 90s, starting in the 90s, the EFCE Working Party education was one of the first that picked up on that and said, guys, under these new conditions, we really need to figure out and define what makes a chemical engineering degree a chemical engineering degree. And there were very strong and weird things happening. You know, there were countries where you got a degree in chemistry, and then you did one course, one semester on technology, and they called it an engineering degree. Well, that kind of doesn't fit. So there was desperate need for a kind of a standard. And the EFCE Bologna recommendations were finally then issued in 2010. They were the first Europe-wide ones, and they applied for chemical and biochemical engineering and some related fields. One of the things that was defined there was that you have to have a 300 credit cumulative degree if you want an MSc in chemical engineering. And that is contested still today, right? And there are countries talking about 240 should be good enough, right? Because their students are smarter than other countries' students. Let me tell you, not true. What is also is, and this was a big thing, and it is a big thing, it's outcome oriented. It doesn't tell a university what it needs to teach. It tries to define what the graduate needs to be able to do. And that's a big, big difference. It was updated in 2020, and it's almost time for a new update. So the Working Party will probably start working on that the next year or latest in 2028, because, you know, these qualification frameworks, they're not something that reacts very fast. They need to be stable, but they get outdated nevertheless. So we'll have to do that, and that will be done. It's still going to look at the typical things of knowledge and understanding, analysis, design, investigation, engineering practice, communication, team working, lifelong learning. These are the things. I'll just show you one thing. And this is actually from the German variation of it, the Processnet Qualifikationsrahmen, but it applies to the EFCE Bologna recommendations quite a lot. This is the requirements of what a bachelor in chemical engineering should be able to do. That's a lot of leaves, isn't it, on that flower? So there's methods, and there's only one little word saying fundamentals up there. There's design. There are evaluation studies, you know, how do you do experimental design? How do you make sure your experiment actually has meaningful literature studies? Nobody does that anymore, do you? Huh? Well, should be easy nowadays. Run an AI over it and then only read 10 papers instead of 100, but you still need to read the 10 papers, don't you? Engineering skills, things are how to run a project, how to talk to other people, interdisciplinary. Right, and this is 2010. Applications, key capabilities. When you then go after 3 years into a bachelor, more things are added, particularly on the methods, design, engineering skills, not so much on the key capabilities. That was, I don't think it's called soft skills nowadays. Changes the names every once in a while, but it's still the same thing, right? So a Master of Science in Chemical Engineering actually has an even larger number of facets that he or she needs to be able to manage and grasp. So we're talking about unusual designs there, new processes, new products, on how to evaluate technology, but also on how to combine knowledge, learn by yourself, responsible care, right, or complex products. Now, when you look at that, one of the questions always is, how does that fit with what is needed in the market? See, there's an engineering degree. We're not talking about knowledge. We're actually not talking about skill. Now I need to find my mouse here. And in 2020, the three big words that you had seen on all the job postings were lifelong learning, project management, and learning aptitude. That was in there. And it fits really well with this. But what's new on the time is data science, data analysis, design thinking, agile methods. Much of that actually is covered under the word of AI nowadays. And they needed to fit into this system, into a framework that was already more than full, right? You all know that engineering degrees are not simple. They're a lot of work. And something needed to come out, right? Because the first law of thermodynamics also applies to courses and course programs. If something else goes in, something needs to go out. Otherwise, there's just not enough space inside. And that is one of the big things of a qualification framework, trying to teach, trying to define what can come out, what do we no longer need to teach, but what needs to be taught, what is new. And yeah, the pet project of your professor from 1997 is probably no longer quite as relevant as it was then. So that's kind of the words. Now today, there'll be other words, things that need to go in that we can, and one of the words that we talk about a lot is ethics nowadays. And I'll leave Florence to talk about for a moment.
Yes. So I can tell you a little bit about the newest projects that we're working on. So one of them is teaching ethics in chemical engineering education. And it actually started in 2023 with a survey. It was before I joined the Working Party. So I'm a rather new member of the Working Party. But so in 2023, we did a survey administered to many European universities asking what they think it means to have ethics in engineering education, how they are currently doing it, and just getting some ideas from different universities. And we got a good number of responses, right? We had from several countries, we had 1 to 2 responses. I think Portugal and India were the most prominent. And so we had a lot of responses. We had good demographics, but the responses were not always representative or comprehensive. And so some of the responses included that ethics are indeed included in their education, mostly in terms of research and design projects, for example, by discussing hazards, social impacts, also questions regarding data, handling of IP, plagiarism. And in some universities, there's really one separate course dedicated to ethics in chemical engineering. But the main message that we actually got from this questionnaire is that there's still a lot of unclarity on what it specifically means to have ethics in chemical engineering. And so there were very different responses, many different subtopics under the same umbrella. So that's based on that questionnaire, we actually decided to continue on the topic and mostly try to raise awareness on what it means to have ethics in chemical engineering education. And Herman, I think you can go to the next slide now. So I won't give you many of the details of what we found out, but we wrote a 2-pager, mostly about what ethics are in chemical engineering, also the changes that ethics pose by having now Gen AI. We defined some learning outcomes of what a chemical engineer should know about ethics or bring ethics into practice after they graduate. And a lot of that will be presented during our spotlight talks in March. So if you didn't register yet and you're very interested in ethics, which all of you should probably be, then please register. There's a QR code on the screen. And so we have very diverse speakers. So we have some people from industry, some people from academia, and actually Kseniya is also going to talk about ethics in the life of an early career chemical engineer. So I'm very much looking forward to that. And so, that's all I have to say for ethics. So I'll give back the word to Herman now to talk briefly about some of the other projects that we're working on.
Yeah. Like all working parties, we have lots of things, and it would be rather boring if we had only one, right? I talked about the STEM skills before. So there was a joint effort between the German federations, several of them, the German chemical industry, and also the EFCE, on the question of what happens if students are no longer interested in STEM subjects, right? The German word for STEM is MINT. And we did write a white paper that was discussed rather prominently in political circuits about how the lack of STEM graduates and lack of graduates actually jeopardizes the welfare of Europe, right? No industry means no welfare. It's as simple as that. Spotlight talks, Florence already commented on that. So we do something else, and it's called the particle technology videos. So there's a set of experiments that we do, and we're taping small 5 to 10 minute videos about different things that happen in chemical engineering, in particle technology. And you see the prior chair of the early career chemical engineers, Sophia, who was our first moderator for the first video. Next one we will tape in March next to, so I'll hope there'll be new ones coming out rather shortly. Some of you will be aware of the Student Mobility Award. This is a very long-running activity of the Working Party. And it came out of the Erasmus programs in Europe, right? We're trying to recognize that it's not all grades that make a good education. It's the diversity of experiences you make, and one of the best diversity experiences you can make is learning abroad, going abroad for an extended period of time and learning there and experiencing what it means to be a foreigner and how other people conquer life, basically, right? So been my great pleasure to be on that panel for the last few years, and it's always very, very many interesting people you meet. The last one that I have here, modern teaching methodology, that's completely out of my scope. I'm always impressed in what you can do if you want to spend the time and teach differently, right? So particularly during my predecessor Eric Scheer's tenure as the Working Party chair, we worked very hard on these short descriptions of what options you have and experiences that people made with trying to do that. And I picked the video capsules because it fits to the particle technology videos, but there's also ugly things like flipped classroom teaching, right? Very tough on students to do, but very good if you want to actually conquer a skill and learn how to do something instead of just that it exists. So that is kind of the breadth of what the EFCE Working Party on Education does and how it tries to scope, to form chemical engineering education, making sure that our degrees remain relevant for our, well, parts of our lifetime at least, and certainly keep Europe competitive in the globalized world. And with that, I think it's time for questions.
Thank you very much, both Herman and Florence, for the very nice presentation and for giving us your for explaining us the activities that the Working Party is doing, and also how the education in chemical engineering is moving, how it was in the past and how you think it will be in the future. I'm sure there will be questions. We as a section, we do have some questions to ask you. Alper, I don't know if you could reserve. Great. Please, for those that are interested to ask a question, you can put it on the Q&A, and it will be asked in the end of this section. But for now, we do have some questions that we would like to ask you, and we will start with a small icebreaker one to start the conversation running. So, what's the strangest thing you've done to get an experiment or simulation to work when it was originally going completely wrong? And I would like to hear the perspective from both academia and from industry, please.
Okay, Florence, you want me to start?
As you want.
Okay. Yeah, I guess I've got to disappoint you on that one, you know. I'm actually a fairly boring person, I think. So I never do anything really strange. I mean, apart from if reading the instructions count. Okay. I've been known to actually read the manual for a new piece of equipment or a new software cover to cover before even starting it up. And sometimes that helps. Sometimes obviously it doesn't. And nowadays you never get instructions that actually help anymore, right? You always go into the internet and try to find who that is. But that's about probably the most strange thing I've ever done. Florence, how about you?
Yeah. So I didn't do many experiments. I'm mostly a simulation or coding person. And when I'm really stuck on coding and I finally decide to give up, I show my problem to one of my colleagues to help me out. And then magic happens, you know, you show your problem and suddenly it works. That's very, very embarrassing. But it means that when you're really stuck, it just means that you need to take a break from looking at the problem, grab a coffee, take a walk, and just ask your colleagues or your friends. It fixed most of my coding bugs.
I think both are very good advices to keep some people when they are stuck on how they can move forward. So thank you very much for answering this. So I think it's time for me and Alper to join the table. If we move to the next slide and ask some more questions related to the education. So looking 5 to 10 years ahead, what should fundamentally change in the chemical engineering curriculum and education, and what must not change? So I think we got a small indication from the very nice flower that you were showing, Herman, but I think we can, let's hear a bit more your thoughts on this.
Yeah. I mean, chemical engineering education is tough, and that will not change. No hope for that, okay? What I personally feel is when you look at the study programs that you see nowadays in the various universities, there are just too many. Just too many. They're all very similar. They have fancy names, and they don't help in the long run. And I'm being very blunt here. I think we need to get back to more broad bachelor degrees. And there's something to be said for things like biochemical engineering. But why does it have to be wastewater chemical engineering, right? So, make sure it doesn't get too small, right? And students don't tend to work in jobs which fit very well the name of the bachelor's degree. And even today, when you apply, you have to explain to your employer why your degree is relevant for the job that they posted. Hey, it would be helpful if the degree is broad enough to cover a lot of those processes, right? MSc programs, that's a bit different, right? You need to have some depth, and somebody needs to learn to actually scientifically and professionally challenge himself and get into some depth. So you know how to get into the depth and how much depth there is, right? Googling something doesn't mean you have learned everything about it. And so not every engineer, for example, needs to be an AI expert, but we need some chemical engineers who really can do that. Like we need people who can do experiments or simulations like Florence does. And it's very tough, but I think university needs to learn that they don't chase every fashionable subject, that not every educational hype needs to be covered by every university. Now I'll stop there because before I make myself more enemies.
Yeah, I completely agree with what Herman said. Also in Leuven, we recently, our bachelor has changed to actually have a common year between all engineering, so also mechanical engineering, civil engineering, and so on, because that strong and broad foundation is really key. And I think in the future, or actually now, digitalization and stronger foundations in AI will just become part of that. But we also have to make sure that we don't sacrifice any core chemical engineering competences for that. And then also, if you look at the current economic landscape, it's important to have this diverse skill set and the flexibility to adapt to different job types. Because, I mean, in Belgium, at least, chemical engineers typically ended up in petrochemical industry, but we also see changes there. So a lot of our students now also go to energy sectors, pharma, and so on. So again, like these core competences and the strong basis, that's really key to be able to adapt to different applications.
Okay, thank you very much, both. I believe that indeed it will be a challenge to try to implement new things without removing all the previous ones. Yeah. And with that, I would like to give the floor to Alper to ask the remaining questions.
Yeah. Our next question is, how should early career engineers balance deep technical expertise with broader skills such as communication and leadership? I think it's a pretty popular question.
Yeah, and a very, very relevant question. I mean, we've talked about fundamentals and these things. Those things, technical subjects, we're actually really good at teaching in classrooms, and you can learn them in classrooms. and you can learn them with example problems and that kind of stuff. And beyond the foundational things, you only need to have a deep technical knowledge of some of the curriculum, right? If you go into simulation, that is deep technical knowledge enough. You don't need to also have deep technical knowledge on experimentation. If you do interaction engineering, you don't also have to be very good in particle technology. That's just not required. But the fundamentals need to be there. Leadership, communications, those broader subject skills, classrooms are not really helpful there, right? You'll need to learn this by trying it out. And the first communication experiments, that's in projects, in presentations, in group work. And it's rather important that they are a significant part of the curriculum to give students a chance to experience and learn. And beyond that, volunteering is a big part of learning soft skills. So honestly, somebody who's never taken over responsibility voluntarily for something is never an exciting candidate. Point?
Yeah. So again, I agree with Herman, and these kind of project works, they are already there in most of the curricula across Europe. And there's a good balance needed between technical knowledge and soft skills for all chemical engineers. But on the same point as Herman talked about, you don't need to excel at every technical skill. It's the same for soft skill. You don't need to be an expert in every soft skill. The best teams are actually those that can leverage unique skill sets of each individual and combine these skills to eventually come to the best outcome.
Yep.
So next question is, what role should failure play in chemical engineering education, and how can we create safe environments to learn from it?
Actually, every university is already a safe environment to learn from failures. Just failing an exam is never good. Sorry for that. That's when you should have done your failures in the tutorials and in the classrooms, right? So asking a stupid question, that's actually not failure, right? Figuring out that something cannot be done, it's not failure. That is actually good engineering practice, right? Particularly in engineering, it's a basic requirement for any R&D project, for any project probably, mapping out what cannot be done. That's not possible. Now, unfortunately, in today's world, we always want to talk about things that are new and successful. We never talk about failures. We never talk about the 29 experiments it took that did not work to find the one that does. And for instance, I guess the same in simulations, right? You run more simulations that don't get you anywhere than that give you good results that you can use. So this very important part of research development is just not popular. If I try to generate a safer space, I'd start with very small changes. If you have a lab assignment, don't ask them to prove something. Don't tell them that it has to work or that it does work. Ask them to find out whether it works, right? So if somebody fails and they do the experiment wrong and it does not work, well, fine. They found a way of showing what doesn't work, and that's good. And of course, they need to give some scientific backup to validate what they've found. But that's the kind of thing I would do. Nothing big. That's not how it works. Just small changes in attitude and whether or not something is an acceptable outcome of a learning exercise.
Yeah. So starting again in the same line as Herman, like failing an exam is never good. But also when it really comes to chemical engineering ethics, when you're on the work floor safety, there is simply no room for failure there. So that's also why it's so important that in education, there is room for failure. And in research and in projects, it's important to fail sometimes because it helps you to reflect on what went wrong. It helps you to troubleshoot. And this is how students build their own judgments. And so indeed, like group discussion, talking about it with your PI, with fellow students, or during class or just during a beer in the evening, that's where you should have the room to talk about failure. But then in research, I also often have the feeling that I failed. And it's because many engineering students we are actually very ambitious. And that's good because that's what drives innovation. That's what drives interdisciplinary work. But it also means that we set very, very high standards for ourselves. And the feeling that you failed might actually be a good thing. It might mean that you're doing well and you're setting these high standards for yourself. So I can just say, get your head up, try again, or move on to the next challenge.
Okay, so the next question is, what are the biggest mismatches between what graduates think industry values and what industry actually values?
Oh man. Okay, we've got another 3 hours, right? No?
I leave this
That's a
one
very tough
completely up to
question.
you, Herman, because I have no idea what this is.
That's a really tough question. Industry is super diverse, and it's made up of people, and the people are even more diverse than the industry just by itself. So basically, for anything you could ask me about, does industry value it? Somebody does. Somebody will. If you ask about what industry generally or mostly on average values, my answer is first and foremost, fundamentals are fundamental. If you don't have the fundamentals, if you're bored by them, that's not going to get you anywhere, right? That is really, really, really fundamental. And we can discuss what is fundamental, but that's actually for those who teach to figure out, right? Those who learn cannot. They'll just have to believe that. And the second sentence would be, I care actually more about what you can do than what you've heard about. It's not about how many of the popular subjects you've heard in class. Whether you have a special class on ethics, a special class on AI, a special class on economics, a special class on something, right? That doesn't get you anywhere and doesn't get me as who wants to hire you anywhere, because you can't do anything with it. You're just aware. Well, being aware and being able to Google it, and you see I have a slight prejudice on this one, that's just not enough, right? So unless you're in academia, the specialized courses you took will most likely not matter much after the first 5 years of employment. But the fundamentals do, so make sure you have a good grasp of them, and then every time you get a choice to do a project, a presentation, something like that, go for it. They are the kind of things that you will have to do as an engineer in industry, while writing an exam is rather infrequent later in life. So that's the best advice I can give. Try to do that, try to take responsibilities, try to work on these subjects, that things that are a little more difficult, and don't collect check marks. That's just not worth it.
Yeah, I'll leave this one up to Herman. I don't have
I was
much
afraid you
experience
would
in
say
industry,
that.
so
Let's continue with last question, but you have already implied this question. So let's move on to questions from audience, if we have.
There is one question, if you can ask Alper.
Yeah, but I cannot see right now. Maybe it is sharing. Yeah. Yeah. One question from Bandana. As a chemical engineer and a foreigner from Asian, what are the challenges and fair chances of getting an academic job in Europe? This question may not be very relevant, but it would be great if I can get some input.
Right, so you want to start that one?
yeah. So we have quite an international faculty here at KU Leuven, and I think the main challenge for the young faculty that are foreigners is that a lot of our education is still in Dutch. So you have to learn the language. And unfortunately, that's the same for all of Europe. There are some masters across Europe in English, and I mean, it's very valuable then if you have international stuff or that, but the teaching load in the bachelor is much larger, and we cannot only, if you want to have an international staff, they also have to learn Dutch to help in the bachelor. Otherwise, the teaching load on the Dutch-speaking PIs is just too much. So I think learning the language is definitely difficult and a must the first years of your tenure track. And chances of getting an academic job in Europe, I think, are fair. We have some Asian people here as well. I won't say that's the same for every university, but there are universities that really also look into internationalization, and they hire people based on their curriculum and not based on where they come from. So
yeah, I'd support that. In large companies like BASF, English gets you basically everywhere on the engineering level. On the shop floor, it's the local language, whatever country you're at. Sometimes even that doesn't work too well, like in Germany. Not everybody on the shop floor speaks German. They speak Bulgarian or Turkish or something like that. So that's a completely new challenge. So if you want to take a foothold in a country, you need to learn the culture. You need to learn to understand the local community, and learning the language is the first step of that. The other thing you need to do, obviously, you need to be a good academic prospect, right? So learning what people expect in a certain country, what your supervisor expects, what your cooperation partners expect, that is another rather important part, just especially for foreigners who wouldn't have the same cultural knowledge. They can't have it, right? But if you get it wrong, then you always lose in the rat race that is an application for an academic job. It can be done. You know, if you do statistics on the academic staff in universities in Europe, one thing that becomes evident is the success of the Greek academic community to find these kind of jobs all over Europe. It's extremely exciting. It's particularly strong in the UK, but it goes all the way to Estonia, right? They're everywhere. So it can be done. They've shown us that it can be done. So don't get discouraged. If somebody tells you it can't be done, it might be their personal fault, or just a mismatch what they thought would be required to what is required.
Okay, thank you very much for the answer. Are there any other questions in the Q&A?
No.
If not, yes, I encourage everyone that had some questions and they didn't manage to ask them, you can please send us to our email account of the Earlies Careers, and I will be very happy to forward this to our speakers so that they can provide you with an answer. At this point, I would like to thank you both, Herman and Florence, for accepting our invitation for
It's a pleasure.
for doing this coffee talk with our section. And yes, I would like to thank you all for participating and hope to see you in our next coffee talk next month. Thank you very much.
Thank you.
Thank you. Bye-bye.
bye.
Cheers.
Thank you. Bye.